All right, greetings Algebra 2 students. Appreciate you finding time to come to your notes. Today we're going to be beginning a new unit. For the next several units, we're going to be going back and we're going to be exploring some of the parent functions that we talked about back in the fall, but looking at them on a deeper level, exploring their equations a little bit deeper and seeing how they apply from various word problems and stuff like that. The first of the parent functions we're going to be looking back at is the square root function. Well, that's not true. The first one we did was the parabola. We've been working with that, the quadratic, for the last several weeks. Now we're looking at square root. So please copy down your title, square root functions, and your objective. Our objective for this day is we're going to learn the specifics for the equations of the square root functions. As always, if you need more time, press pause and then hit play when you're ready to move on. There is a lot of information in this particular lesson, not a whole lot of math, just a lot of information, so you may find it necessary to press pause more than usual today. Okay, so let's get to it. All right, now obviously we've been spending a lot of time here recently looking at the quadratics, which of course graph our parabolas, talking about their vertices and lines of symmetry and all of that kind of stuff. Okay, but going back, okay, reviewing something that we've already talked about again here recently as well, we looked at the inverse of the quadratic. And we've been talking about this one here recently. We saw that we could take a parabola, y equals x squared. We could inverse it to make it x equals y squared, and that would send the parabola sideways, okay, by taking its inverse. Okay, so we should be familiar with that. But another thing that we also said, of course, is we spent the majority of our time looking at the vertical parabola, the y equals x squared. We've moved them all around, we've turned them upside down and all that kind of stuff, but we spent very little time actually looking at the horizontal parabola. And the reason we said that was true, or that was the case, was because we basically were not interested in graphs that were not functions. Okay, so again, this is all review information, but go ahead and jot it down again. Okay, we were not interested in the horizontal parabola because it failed the vertical line test. Obviously, vertical line makes contact with the horizontal parabola twice, and that means we have an x value that has more than one y value, so that is not a parabola, or not a function, rather. Okay. Now, what we're going to do is we're going to alter this equation somewhat, and we are only going to look at part of the parabola. Okay, so let's take a look at what part we're going to look at. Okay, if we were to take the absolute value of this inverse, okay, taking the absolute value of the inverse, here's what ultimately happens to our horizontal parabola. Okay, as you can see, no longer does he have two legs extending from his vertex. He only has one. Okay, and that's basically the equation that we're talking about, taking the absolute value of the inverse. Okay, or if you put it in horizontal parabola terms, it would look like that: the absolute value of x equals y squared. Okay, and saving you from doing a bunch of the boring math, or explaining to you a bunch of the boring math, when this guy is simplified, which is actually not as easy as it may sound, he ends up looking like this: y equals the square root of x. Okay, now this is an equation we have seen before this year, and he's going to be the focus of everything that we're doing in this unit. That is the parent square root function. Press pause if you need more time. I'm about to move on. Okay, now we spent the last several days, several weeks, okay, working on parameter changes with our quadratics. Now what you're going to see is a lot of the parent functions and the conic sections that we're going to be getting to this semester. A lot of the same rules and structures and parameters are going to hold true. Okay, and the first one we're looking at is our vertex. Our square root function is going to have a vertex, and our vertex is located exactly at h comma k, exactly like our parabola was. Okay, so h comma k remains to be the truth. And as such, our square root function can be moved around inside of the graph by adjusting our equation with the h and k values. When you add those into the square root function, the parent square root function, they look like this. Of course, h directly affects the x value. Okay, so he is underneath the radical with x, and k affects the y value. So he is a constant that is attached to the end of the expression. Please notice that the signs remain the same as they did with the parabola. Okay, with the negative for the h being built into the formula, the positive for the k being built into the formula. Now, just like with our quadratic, we can turn our absolute value, or I'm sorry, our square root functions, we can turn them upside down by changing the sign of the entire term that's affected by the square root. Now, we saw this with parabolas, simply changing the sign of the squared value. Okay, but with an square root function, a little bit different. We got to pay attention to the positioning. If you reverse the sign of the entire term that is affecting the square root, then you have turned the graph upside down. Okay. There is a different way to change the sign of this x, and that would be inside of the square root. Okay, and that would actually turn our square root function backwards. So we can turn our square root function backwards by changing the sign of the variable and doing it underneath the radical. Okay, so you gotta pay attention. There's two different instances there. One of them is changing the sign of the entire term dealing with the radical. That turns it upside down. The other is simply reversing the sign of the variable that is interacting with the radical. That's going to turn it from left to right, back to right to left, stuff like that. Okay, there is one other adjustment that can be made, and that adjustment is going to be, of course, changing the speed with which our square root function rises or falls to infinity. Okay, and that change is made by changing the coefficient of the variable dealing with the square root. Okay, so there's actually two different ways that we can change the variable dealing with, or change the coefficient dealing with the variable that's working with the square root. And that would be to change the coefficient of the variable actually under the radical, like you can see in the first example, or possibly changing the coefficient of the entire term dealing with the radical, which will indirectly affect the x as well. Okay. Now there's a few parameters that we need to know associated with this a value that was just brought into the problem. Hopefully you should remember them. These are the same as they were with the parabola. If a is a number smaller than 1, then that is going to cause our square root function to go to infinity slower than it normally would have. Or if a is a number larger than 1, that's going to cause it to go to infinity faster than it wanted to. Okay, and one other distinction, okay, you can already see in the equations that are on the screen right now. Okay, there's two different places that we can affect the coefficient of that variable that's interacting with the square root, but it actually does make a bit of a difference as to where you position it. Okay, so if the value of a is outside of the radical, it's going to have a larger impact than it would have if a was underneath the radical. Okay, because I mean this makes perfect sense. If you get to thinking about it, if you put it underneath the radical, then you have the square root of that number, okay, as opposed to the entire whole number if it were outside of the radical. Okay. So to think about it, loosely, let's say a was a 9. If you put the 9 underneath the radical, well, the square root of 9 is going to make that 3. That's a smaller number than 9. But if you put the 9 outside of the radical, well, hey, 9 is 9. Okay, the radical cannot affect that. So if the value is outside of the radical, it's going to have a greater impact on the speed of the graph as it moves towards infinity. Okay, so I gave you 3 little basic sketches there so you can kind of see the difference. Okay, obviously on the left-hand side we have the parent square root function. Okay, that's his normal positioning. Okay, on the next one, the one in the center, I've changed the coefficient underneath the radical, and you can see that has caused the graph to go faster towards infinity because the number is larger than 1. However, if we move that 3 outside of the radical, now you can see it's having an even greater impact for being outside of there. So keep that filed away in the back of your head that that's the way this works. Okay, now what we're going to do is we're going to look at some specific examples. I'm going to work a couple with you, and you're going to work a couple on your own. So let's take a look at how this is going to work for starters. Okay, here we have an equation, a function that is given to us. Okay, and we are going to see if we can decode the information that is in this equation in order to answer the questions that are provided. Okay, so I'll give you just a second, write the function down. You may want to press pause and write the questions down as well, and then you can fill them in as we go. Okay, so let's start with the first question. Where is the vertex? Okay, well, we can read right out of the equation. Our h should be directly attached to our x, and our k should be hanging on to the end of the equation. Okay, so you're looking at our vertex. As you can see, our h value is a 2. Okay, we have a 2 attached to our x. Okay, is that supposed to be a positive 2 or a negative 2 or what? Okay, if you remember back to the formula said the formula or the equation is supposed to say x minus h. Okay, it does not say minus, which means the 2 must have come equipped with its own negative sign to cancel out the negative that was already there. So it should be a negative 2. And then where is the k value at? Obviously it says 5. Okay, the formula says that's supposed to be a positive 5, and it is a positive 5. So the answer is negative 2, comma 5. The graph, is it moving up or down? Okay, now this is a little bit different from our parabolas. Our parabolas only went one of the 4 directions. They went up or left or down or right. They only had those 4 choices. But remember, a square root function is moving in 2 directions at once. Okay, so it's actually heading to infinity in 2 different directions. We have to identify up or down. It's going to be one or the other. And left or right, it's going to be one or the other. Okay, so let's have a look at the signs. How do you decide if a graph is moving up or down? Okay, well, the up or down has to do with the overall sign of the square root term. Okay, so in this case, our square root term, the entire thing is positive. It is supposed to be positive, so that means no change has been made. This graph is moving upwards. How about left or right? Okay, now left or right is depending on the variable that is under the radical. Okay, so looking specifically at the x, it is supposed to be a positive x. It is not. It is negative. That means it is moving the opposite direction horizontally than it should have. It should have been going right, but the sign change is going to send it to the left. Okay. Now, is the graph rising or falling, faster or slower, or the same as it should be? So now we're going to pay attention to the coefficient of what's going on with the variable associated with the radical. Okay, and the variable associated with the radical. Okay, we have a 1/2 outside of the radical. So that 1/2 is directly affecting or indirectly affecting the coefficient of x. And 1/2 is a number smaller than 1. So is that going to cause it to rise to infinity faster or rise to infinity slower? Well, we already know it's rising. Okay, so we're not necessarily trying to pick one of these two. We already know it's going upward, so it is rising. Okay, the question is it going faster or slower, or the speed that it's supposed to? Well, a smaller number, it's been changed, so it's definitely not the same, but a smaller number causes it to move slower. Okay, so there are basic telltale indicators that we ought to be able to read out of our equations when everything is said and done. Now I want you to copy this equation, and I want you to basically answer the same questions as the problem that we just did. Now please do not shut off the audio or the video just yet, because I'm not done with examples. Just saying that before the next class, I want you to have answered those 4 questions for this equation. Y equals the negative of the square root of negative x minus 6. Press pause if you need more time to copy that down, because I'm about to turn the page and look at the next example. Okay, for the next example, here we have another equation. Okay, x equals 1/2 of the square root of y minus 4. Okay, we're going to answer the same 4 questions as we did on the previous 2. So press pause if you need a little time to jot this down, and then hit play when you're ready to start working it out. Okay, so where is the vertex for this square root function? Okay. Now, obviously, we're looking for h and k, but one very important piece of information that you better have noticed is that the variables have been reversed. We are looking at an inverse of the square root function. It no longer says y equals something to do with x. It now says x equals something to do with y. Okay, so it's going in the opposite direction, vertically rather than horizontally. Okay, so let's see what we've got here. Where is its vertex? Now, in this case, remember that it would be the k information that is attached to y, okay, and the other constant would be h. So in this case, it is the -4 that's sitting out there that is our h value. The question is, should that constant be positive or be negative? Okay, well, that constant should be a plus. So that means 4 must have come with its own negative sign. So our h value is -4. Okay, and what is the constant that is affecting y? There doesn't seem to be anything written down about y, so that means the constant there must be 0. Okay, so our vertex is at -4, 0. Okay, now we know we're looking at an inverse, but as we already said, all of the square root functions, they're going to continue to infinity in 2 directions, one of them being up or down, and one of them being left or right. So let's see what we're supposed to be looking at here. Okay, now the inverse function, just for reference, it should look like this. Okay, we're going to start off at the origin, and instead of going up into quadrant 1 and then turning towards the right, it's going to go right in quadrant 1 and then turn up. Okay, so that would be the idea of the parent inverse function. Okay, so let's see what this guy is now doing. Okay, is it moving upwards or downwards? Okay, well, the up or down idea, okay, was associated when it was the non-inverse. Okay, that was with the whole the sign of the entire square root function. Okay, but we're looking at an inverse this time. Okay, so that means we're not looking at the sign of the entire function. This time we're just checking, has the y value been reversed? Okay, so now we're just looking underneath the radical. Look at y. Has its sign been changed? Okay, it was supposed to be a positive. It is a positive. Nothing has been changed there. That is moving upward. Okay. Now, left or right, that would involve changing the direction of the entire problem here. So that's going to be a question of, okay, has the entire square root term, has its sign been changed? The entire square root term was supposed to be positive. It is still positive, so it has not been changed. So we are moving to the right, just like the function over here on the left shows. Okay. Now we already know that it's rising. Okay, so it's not a question of whether it's rising or falling. The question is it doing this faster or slower or at the same speed that it should be doing it? Okay. Well, once again, like the old other one, we have a fraction in front of our square root. Okay, so we have a slower value, a number smaller than 1. So it's going to slow our graph down. Okay, so that means we would select slower. Okay, because it is moving at a slower rate than it should going to infinity. Okay. Same thing as on the previous page. I would like you to copy this example down and see if you can answer the 4 questions that are above about this question, or this equation. X equals the square root of, should say 2y. I apologize, I've got an error in my notes there. Should say 2y plus 3. All of that is underneath the radical, and plus 1. Okay, so copy that example down and see if you can answer those 4 questions as well. I would like you to answer those 8 questions before you come to the next class. Have that done, and then we'll see if we can get the correct answers together. I appreciate you taking time to get your notes taken care of, and I will see you in class.